Hi dear students, this is the second part of traffic simulation. Here we will see what are the different stages involved in building a traffic simulator. So the basic steps involved in the development are same irrespective of the type of model that we are using. The stages or the steps remains to be the same. So the various steps involved are, first of all, we have to define the problem and we have to create a model objective. We have to formulate the objectives. So for what is the purpose of doing this? Okay, so we have to have a problem which we are trying to simulate it using the computer simulation models, or we will be modeling the situation that is actually there in the field. So we have to have a model objective and we are trying to give a solution to a problem. So first of all, we have to define that. Then next what we need to do is we have to define the various systems that we are studying. So basically a traffic, it consists of the roadway, the vehicles are running over the road, then there are drivers who are controlling it, there are management or there are control measures which control the vehicular movements. So we have to define the system, we have to get the details of these characteristics of the various elements of the traffic. Okay, so that we need to define. So for that we need to go and collect the data. Say if we are going to design a particular road stretch, or if we are going to model a particular road stretch, the roadway geometry, the vehicle composition, the volume of traffic and the speed, the design speed or the speed with which vehicles running on the road, all these details we need to collect from the field. And then comes the model development. Okay, it basically consists of 3 steps. First of all, we have to generate a vehicle and we need to update the position of the vehicle at every given time, and then we have to do the analysis. So that is basically comes under the model development. So once we develop the model, we are developing in a generalized way, then we need to calibrate the model. So we are applying certain equations for the model development, and then we need to see whether this is applicable for the current situation. Say for example, I am generating a model and I want to see whether the model parameters are they okay for the current situation. So we have to calibrate the model parameters according to the field data. So that is the next step, model calibration. Then comes model verification. So we have to verify whether the model is working properly. Say for example, we have an intersection and whether all the lanes in the intersection is properly being used by the vehicles there. Okay, or we have to see whether the vehicles are running over the road. If they are colliding, we are applying the car following theory. And even then, if the vehicles are colliding each other or if there is rear end collisions, so all these aspects, whether the model is working properly, that we need to verify. Then comes the validation. So validation means we have created the model and we need to see how much it is matching with the field data. So we have some performance measures. So we will be collecting some performance measures from the field. Say we are saying like this is the speed with which vehicles are traveling, and we are simulating something and we will be getting a speed out of that. So then we will be validating how much is the difference in the speed, or we are getting the volume. So we are actually comparing the volume between the actual and the, or simulated and the actual, or simulated and the field data, and we will see how much is the error that is happening there, and accordingly we need to minimize the error and we need to validate our model. Okay, and finally comes the documentation stage where the results of this is documented and presented. So these are the various stages that comes in a traffic simulator. The model development basically consists of 3 steps. The framework of a model, it mainly consists of 3 processes. So first one is the vehicle generation. So we have to generate the vehicle. And again, what type of vehicle it is. What is the headway at which, or what is the time gap, or what distribution we need to follow in order to generate the vehicle. At what time interval does the vehicle gets added to the traffic stream. Okay, so that is the first thing. We have to have first of all a study stretch. Say for example, the one given here in the second figure, you can say this to be the study stretch. So we are going to introduce vehicles into the study stretch. So first thing is we have to generate the vehicles and how the vehicle needs to be generated. Okay, that again depends upon what is the traffic volume there, what is the traffic composition there, and what is the headway distribution. So accordingly, we have to generate the vehicle. And once the vehicle gets generated, we need to introduce that into the traffic stream. Okay, so after introducing that into the traffic stream, the second step is we need to update the vehicle position. So at every given time interval, or at every given instant of time, how much distance a vehicle should move, then only it can be continuous, right? So we have to have some background, or we need to have some model to define the vehicle updation. The vehicle position gets updated based on certain rules. So that rule we need to define. Okay, is it collision avoidance rule, or car following, what type of car following we need to follow, or if the vehicle needs to change the lane, or if it needs to overtake, which model we need to use there. So we have to have a vehicle updation rule. So once this is being done, we will be tracking the vehicle over the study stretch. Maybe we can get the microscopic data, the trajectory of the vehicles can be tracked, or we can see how they are interacting with each other. So those parameters we can get, or we can collect this at the macroscopic level. What is the how much volume of vehicle is traveling, or if this is a particular volume at which the vehicles are traveling, then what about its speed? The stream speed we can get, or we can get the headway between the vehicles. So the different parameters we can collect from the simulation model, and then we can analyze it. So the third step is analysis. So these are the three main steps coming under the model development. First of all, we have to generate the vehicle. Once the vehicle generated, and if we are introducing that to the traffic stream, we need to update its position, and then we will be doing the analysis. So these are the three steps involved in the model development. The overall framework for the microscopic traffic simulation model is given here. So first of all, we start the process. The flow diagram of the traffic simulation is given here. We have to give inputs and we have to initialize it. So inputs like road geometry, the vehicular characteristics, the driver characteristics, all those we have to give as an input, and we have to initialize the program. And then comes the vehicle generation, which is done based on the headway distribution. And then comes the vehicle placement. So generate the vehicle which are generating need to be placed on the road. Okay, so the next step is placement of vehicle of the road, and once the vehicles are placed, this vehicle needs to move. So the next stage is vehicle movement. Usually in the case of a divided roadway, there are no intersection and there are no other roads merging with this traffic stream. We basically move the vehicle by the car following theory. And if it needs to overtake, so we need to apply the overtaking models or the lateral shift model. So there are certain criteria to be met for updating the vehicle position. So one is the car following. So the every time interval, the vehicle positions are updated based on the car following theory which we are using. So we have seen one example when studying this microscopic traffic models. Like we have seen the car following models, like the different car following models in the we can classify that into the collision avoidance model or the safe distance model. There can be response stimulus model, there can be psychophysical model, or it can be optimum velocity model. So there are different models available. So based on which model are we applying, so again which model to apply to a situation again depends upon, it's a choice of the simulator who is simulating it. Okay, so we have to select a model which is most appropriate for a given location. So in a mixed traffic condition, we have to select a model which is appropriate, or which is replicating the mixed traffic condition. Accordingly, we need to select the model. So the vehicle positions are updated based on this car following theory. And if the vehicle needs to shift the position, so lateral shift models or gap acceptance models are available for the vehicle shifting, because gap acceptance means when we are shifting from one lane to other, we will be actually calculating how much gap is there between the two vehicles in the nearby lane. So if we have enough gap, then only we will be shifting our vehicle. Otherwise, if we shift, it may lead to collision with the vehicle moving by the side of us. So we have to analyze the gap between the vehicle, or the vehicle need to analyze the gap between the vehicle in the adjacent lane, and then it will be shifting. So there are certain set of rules we need to provide here in order to update the vehicle, or in order to move the vehicle, or you need to update the vehicle position at every scan interval, we have to apply these two main theories. One is car following, another one is lateral shift, or if it is overtaking, then we have to apply the overtaking models also. So once we do the vehicle updation, then after every instant of time, it will be checking whether the simulation time period is over. Say for example, we are simulating it for 15 minutes, maybe we are simulating it for half an hour, so it will check whether the simulation time is over. If it is over, the program will stop and it will give the result, otherwise it will go on continuing this. Okay, so these are the framework, or these are the steps involved in the microscopic traffic simulation.